Today we're going to be working on Leetcode question number 239, a sliding window maximum. You are given an array of integers nums. There is a sliding window of size k, which is moving from the very left of the array to the very right. You can only see the k numbers in the window. Each time the sliding window moves right by one position, I return the maximum sliding window. So in this case, this example is very self-explanatory. We have been given these numbers. The window is 3 digits long, and the output is gonna be this one, because first he's gonna looking for the first 3 and the maximum is 3, so he's gonna be returning 3, and he's gonna keep moving the window uh, by one digit to the right, and every single time we are looking for the maximum number uh, in that window. The algorithm is gonna be that we're gonna start from the leftmost index and we're gonna iterate. Basically, we're gonna be iterating through the whole nums. Every single time there are mainly there are two logic in the algorithm. One is we're gonna make sure that when we're gonna be using the queue, we're gonna be basically be using the DQ so that we can actually use both ends depending on the conditions. So we want to make sure that the top of the queue is the maximum at all time, and instead of actually thinking about the window size, we are just gonna iterate from the leftmost element to the rightmost element, and every single time we're gonna just look at the length of the sliding window. Basically, we're not gonna wait that okay. Our logic is not gonna wait for the window to be completed, uh, which in other words it will, but I mean we're gonna be it's gonna be an like the loop which we're gonna be using is from I0 zeroth element to I equals to the last element. That being said, it's first of all, let's start with the base conditions here. The sanity checks here. The If the num is equal to uh, null, or the k less than equal to 0, right? In both cases, we're just gonna be returning 0. Return basically, sorry, we're gonna be returning an empty array. So that would be like this. It is size of 0 elements, and it's a new array int. Okay, now we need n, which is gonna be the size of the length of the nums, and then we're gonna need our result. So our result array is gonna be equal, we're gonna initialize it as a new int, and the size of that is gonna be equal to n minus k plus 1, because if you look over here, the n is 8, the k is 3, so 8 minus 3 plus 1 is equal to 6, and the size of our output was 6 too. And we're gonna initialize our result index, which we're gonna be filling up, equals to 0. Now for int I is equal to, actually before that we need a q, so for that we're gonna be using a dq of integer. Dq is equal to new array dq. Okay, int I is equal to 0, I is less than n I plus plus, right? every single time when we are wherever our eye is, we are gonna make sure that the queue is gonna be at the, like the queue's main, like the first element is the maximum element. So for that, every single time what we're gonna check is, first of all we're gonna check that if the range is out of and the other thing is, inside the queue we're going to be saving the indices, not the value of the elements. So the first thing we want to check is it out of range now, right? If it is out of range, we're going to just remove it from the queue. The queue is empty. So while it is not empty and the dq dot peak is less than I minus k plus 1. So while that is the case, we're gonna say dq dot poll, basically saying if uh, if the element inside the queue, whether it was the largest if the index inside the queue is actually out of range, just throw it out. The next thing we want to check is if what the current element, the new element just came in, right? We're gonna compare that and the largest element in, which is which we can get from the queue. We're gonna compare that, and if that is the if the new element is bigger, we're gonna keep removing the queue. So while the t queue is empty, so while it is not empty that and the nums of the dq dot peak last is less than the nums of I, you're gonna keep polling it. dq dot poll last. Then regardless of what the value is, we can just put it inside the queue. dq dot poll dq dot offer in order to put it in, right? And we are, as we said, we are gonna be putting in the indices, not the exact and the actual values. Okay, and the last thing we wanna do is to fill up our result only if the I is greater than k minus 1. Yeah, that's when we start filling up the result indices, the result array. Oops, that is gonna be equal to nums of dq dot peak. And once we come out of this for loop, we can just return the R. Okay. Yep. So we have a typo here. And this time the answer is not right. So we are starting, first of all, the length of the R is good, right? And we are starting from I0 to n less than n. Good is good. Then this needs to be equal to 2. Yeah, because we're gonna start filling it up once it is even equal, when it becomes equal to k minus 1. Okay, and it works.